All right, here's an example of the three Pythagorean identities and how they, just showing that they work for a particular right triangle. And then I'm going to show you a couple of examples of how you use the trig identities to get how you use the Pythagorean identities to get one trig function from another. So here's a right triangle, 3, 4, 5. It's one we use quite a bit because the edge lengths are nice. The angles aren't particularly nice, but the edge lengths are nice. So if I look at, pick an angle, let's look at this angle up here. Right? I'm going to call it theta. So the sine of theta is opposite over hypotenuse, 4/5. The cosine of theta is adjacent over hypotenuse, 3/5. If I look at sine squared theta plus cosine squared theta, I'm looking at 4/5, that's the sine, square it, 3/5, that's the cosine, square it, add them up. So this would be 16 over 25 plus 9 over 25 for a grand total of 25 over 25, which turns out to be 1. Sine squared theta plus cosine squared theta will always be 1, and hence for that angle too. The other trig identities, let's just take a look at them. If I look at 1 plus the tangent squared theta, these are the other Pythagorean identities. I think I said trig identities. They are trig identities, but they're specifically Pythagorean trig identities. So this would be 1 plus, now the tangent of theta is, this is theta, opposite over adjacent, so 4 over 3. And I want the tangent squared. So I'm looking at 1 plus 16 over 9. Getting a common denominator, let's write that as 9 over 9 plus 16 over 9. This is 25 over 9. Notice that the secant squared of theta is, what's the secant of theta? Secant of theta is the hypotenuse over the adjacent side. So 5 over 3, I almost wrote it upside down, 5 over 3. If I would take that and square it, I've got the secant squared, that's 25 over 9. Notice that's the same thing. Secant squared theta, 1 plus tangent squared theta, they both give you the same result, 25 over 9. And lastly, let's do the let's do this one, 1 plus the cotangent squared theta. Cotangent is the reciprocal of the tangent, so this looks like 1 plus 3/4 squared, which is 1 plus 9/16, which, getting a common denominator now, 16. This is 1 over 16. Sorry, 16 over 16 plus 9 over 16 for a grand total of 25 over 16. And if I look at the cosecant squared of this angle, cosecant squared of theta, the cosecant is 5 over 4. If I take that and square it, I get 25 over 16. That should be the same thing. Yes, it is. Those two are the same. So there's verifying that for this triangle, the three Pythagorean identities are true. Okay. Now let's take another look at these and say, suppose I know. What if I know that tangent of theta equals 7 over 5? What can I do with that information? Well, I can get from that, well, several ways I think of this. I could draw a picture, which we've done in a previous video, where I would actually, is that a previous video? Anyway, in another one of the videos, I draw the two sides. I've got the opposite side and the adjacent side to this angle right here. I've got 7 over 5. I can use Pythagoras to get the third side, and then I'd know all the trig functions. But I want to look in terms of this Pythagorean identities. I know that the secant squared theta is 1 plus the tangent squared theta. So this is 1 plus 7 over 5 squared, which is 1 plus 49 over 25, which is 25 plus 49 over 25, getting a common denominator, for a grand total of, that's 74 over 25. So the secant squared of theta is 74 over 25, which means that the secant of theta is the square root of that. And to take the square root of a fraction, you take the square root of the top and the bottom. So this is the square root of 74 over the square root of 25, which is 5. Okay. So knowing the tangent and that identity, I could get the secant. Of course, once you know the secant, you could take the reciprocal to get the cosine. So the cosine must be 5 over the square root of 74. Of course, once you know, because with the tangent, you could have just taken the reciprocal to get the cotangent. And in order to get this, let's see if I can get the sine. Well, I can get the sine because I know that sine squared theta plus cosine squared theta equals 1, which if I solve for sine squared, that's 1 minus the cosine squared theta. That's where I just subtracted this over to the other side. So now, plugging this in here, I've got that the sine squared theta is 1 minus the cosine squared theta. Well, the cosine of theta is 5 over the square root of 74. I want the cosine squared. So this is 1 minus 25 over 74. And getting a common denominator, I've got 74 minus 25 over 74. And 74 minus 25 is probably 49. Yeah. 49 over 74. So this is the sine squared of theta is 49 over 74. That tells me that the sine of theta equals the square root of that, which is 7 over the square root of 74. Right. I think that corresponds here in that, I should say once I know the sine, I can take the reciprocal to get the cosecant. So I've got them all. But starting from the tangent, I could get the secant, and then from the secant I could get the cosine, and from the cosine I can get the sine, and from the sine I can get the cosecant, and then I've got them all. I think if we did use the Pythagorean theorem here, 5 squared plus 7 squared is 74, so this is the square root of 74 on this side. And I believe all the things correspond here. This cosine is 5 over the square root of 74. The sine should be 7 over the square root of 74. Is that what we got? Yeah, 7 over the square root of 74. So you can think in terms of the picture, or you can think in terms of the Pythagorean relationship.